Okay, so the Ray Sop is what we're gonna be looking at today, and yeah, I guess I'm excited. Yeah, let's go do this. Chill. Okay, so to begin our whole lesson, double click on the object geometry node over there. Now I got a grid over here, which I'm actually going to rename to grid low, and I'm gonna go ahead and make another grid, and this one's gonna be grid high, as you might expect, right? So grid high, meaning resolution, as in high resolution, and we'll make the resolution 300 by 300. And the thing to note over here is that both of these actually have the same size. Now you might want to keep that in mind later on, but if you know they're not different sizes, you can use the match size node to match them up. But let's go ahead and on our grid low over here, I'm gonna go ahead and drop in a color swap. We're gonna actually paint on this, and we want to paint on a black surface. I'm gonna just go ahead and change all of this to 0, 0, and we're gonna paint on this. So paint top. Now you're gonna be painting with the red color, and we're gonna be using the red color later on to extract the attribute data from it. Now for the foreground color, I'm gonna change it to red. I can change it to green or blue. We just RGB values pretty much. So we're gonna be messing with the red in our case. And for the brush, you can actually mess with the radius depending on how you want, or you can actually, while on the viewport over here, press the shift key and middle mouse click to increase the brush radius, and you can tell on the parameter editor that the brush size radius actually increasing, and now you can actually just paint your road as is. Now for one, my grid is kind of a low res, so I'm going to change it to 50 by 50, so that way everything kind of, I'm going to reset all changes, then I'll go ahead and paint one more time after resetting my grid, so I can paint a little bit more detail now, just a little bit more detail. Now if you do remember, we are actually painting on a low res, right? And you can actually mess with some of the stuff like the opacity to make it not too red. In our case it's too red, just in case you want some soft detail. And I'm really not here to show you how to paint, so I'm gonna go ahead and stop right there. Okay, so we got our paint stop. Now we can actually go ahead and just transfer the attributes using an attribute transfer, but being that this is a Ray Sop tutorial, we're gonna drop in array. Now it asks for two inputs. The input one is the ray points or primitives, in our case, which is the grid high resolution, and the ray points is the low res version of it. And once you click on that, technically by default everything it should say transform points, but you really don't need that. What you actually need is actually import attributes, and you could actually import all the attributes, but in our case all we need is the color, so you can remove the asterisk, and that just transfers all the color attributes onto your high resolution grid. As you can tell, now it has all the colors, just like how you would actually use an attribute transfer. Now the only thing that's actually a little bit different, I would say, is that nothing is different. So why are we using the Ray Sop? Well, it's just a showcase, so we're gonna go ahead and continue with the showcase. So it's not really a tutorial lesson or anything like that. So we're gonna create a verb sop and just drop down a verb sop, and what we're actually gonna do with the verb sop is some few things. For one, we're gonna create a terrain, being that we're gonna actually have a road kind of system on this. We're gonna have a flat surface on this and terrain surface on wherever the red spots and I actually painted on. So first things first will be to realize that we're actually just messing with the y attribute, or the y value in the position data, being that the x and the z remain the same, as in the grid remains where it's at, but how high and low it goes is actually what we're going to change. So in order to manipulate just the y data, you can drop in a vector to float. So vector to float, if I can get the right one, vector to float, And what that does is actually just split up our vector to the three main components, and I know we're gonna have to join them up later on for right there, so we're gonna have to drop in a float to vector. I'm gonna go ahead and just bind this up. I know the x and z don't change in any way, so if I just go ahead and plug this back in, everything still remains the same. Now what we need to actually go ahead and do is kind of create some data in between this little portion over here and plug it back in. Now under the patterns over here, we can actually drop in a turbulent noise with that ask for position data. Cool. Now you can actually just go ahead and plug this in directly to this right here, and it's just gonna, you know, create this little terrain thing, you know, kind of sorta, which is cool. But we can go ahead and take it up a notch higher. We can drop in another, under the patterns you can drop in an anti-alias noise, flow noise, plug this in, and we can add those up, add both of them up, which is kind of cool. Now we can actually just go ahead and plug this in, and that creates a more different kind of stuff. So you might want to play with some of the stuff over here, but honestly I don't think time allows for me to create a perfect terrain, so well, I would say that's good enough. And just for play, just for anybody that knows me kinda sorta, they know I like to play with stuff. So under the matrix over here, you can create a transform matrix. No, I need a which one is it? Matrix. It's rotation. We can do a rotation matrix. And no. Oh my goodness, I'm not even supposed to be doing this. It's supposed to be now you can tell I haven't been doing Houdini for quite a while. It's a make transformer. Okay, so that's the node that you're supposed to get. Now what I can actually go ahead and do is multiply my position data right here with the matrix and plug this data into this right here, if that makes any sense. I'm just playing with Houdini as of right now, as you can tell. I'm gonna move this guy a little bit. Now with this, you can actually just go ahead and rotate this in I would say in Y or something, and now you can just get different kind of values. Hopefully this hasn't froze. Come on. Okay, so now you can get different terrains by just rotating that. And probably let's see, scale this, what happens. Well, probably scale it down. Well, you get the point. You need just to play around with the settings a little bit. Now that's fair and dandy. Let's go ahead and keep on with this. Now in our color, which we're looking at right now, which is being imported right here in the point color attributes, we need to get the red color, so we can use a vector to float, and what we can get is the red attribute from this, which in our case is the first one. Now this is RGB, so red is the first one. What we can go ahead and do is actually, from the data that's getting an output over here, now don't forget that if you actually look at this, technically what you're looking at when you look at the spreadsheet, you can see the value is actually 0. Now if you multiply a number by 0, some values are 1 and some values are 0. So if you multiply any number by 0, the value will be 0. So in our case, what we need to do over here is actually multiply our output by the color over here, which in our case you find that only the red attributes get the mountain area and everything else gets flat, of which you actually want the reverse. So what you actually want to do is, under the math, you actually want to drop in a complement VOP, which now does the exact same stuff, only now your road is you know, flat and the terrain is actually bumpy. So that is kind of cool, I would say. And pretty much you can actually say that the Ray Sop wasn't really a tutorial. but it's just an excuse to have a tutorial. Now you can take it up a little bit, take it up a notch higher. Being that we're getting all the attributes from this, we can actually drop in a ramp parameter, which actually needs a value of 0 to 1. What you actually want to do is actually recolor our if I can actually go plug this in right here, plug in our values. As you can tell, it actually goes from that to that, 0 to 1. So black is the lowest and white is the highest. But what you really want to do is actually fit this range, fit range. All that's gonna do is actually just remap the whole thing into a 0 to 1 range, so that way everything falls in what the ramp parameter actually really wants. And now we can actually just plug this in into the color, and now we can actually go up, and as you can realize that nothing actually changed. So actually now we can change this to red on the highest color. Don't ask me why I always use red, I don't know why. Then you can choose even in between colors. So in our case, you can use a green. And now you can have this terrain kind of sorter, which is really relevant, being that there's nothing usable in this. And I would say pretty much that's it for the fast Ray Sop example. And I'm gonna go ahead and drop in an attribute just to showcase that this tutorial is completely irrelevant. Now I got my little terrain and everything looks good. Now the Ray Sop was just a primer. Now I'm gonna go to the real example, which actually is how to manipulate data using the point normal and the point distance in this particular case. So this, I guess, was just something I need to take off out of my library. So if it ain't useful, sorry, just thought I'd have it out there. So let's get to the Ray Sop example 2. Okay, so we get to the meat and bones of the Ray Sop. This was just an example, as I said, just to get it off my chest, I would say. Now in this particular case, I got a grid, which is just a grid primitive, and I'm using a font Sop in this particular example, being that a friend of mine keeps on asking for graphics, graphic intros in Houdini, so I'm kind of heading that direction. Zevi, you know who you are. Okay, so I'm gonna just drop in my name, nothing fancy. I won't even change the font. So first problem is that we need to actually subdivide this into a little bit of a high res, that being that right now it's just primitives, just single primitives. So we're gonna go ahead and drop in a for each node, and what that's gonna help us do is actually just work on one primitive and everything else gets reiterated over the loop on every single primitive. So we actually need to change for each primitive in this particular instance, and once we enter, you realize that we're just working on one primitive, but what we're gonna do on this one particular primitive is actually gonna get replicated on all the other primitives. So we're gonna drop in a triangulate 2D. Now technically this is for cloth and stuff, but we just need to redefine our mesh. So we're gonna refine it, and you have to play with the settings a little bit depending on how low you want the resolution. Not that low. Wow, thing is so delicate. Okay, right about there. And being that you don't have the constraint primitive set up, in that case you just choose the number 0, being that you only have one primitive, and now you get your font or your letters accordingly. Now if I go back up, it's been replicated on all the other primitives. Alright, so that's pretty much the setup. Now I'm gonna go ahead and drop in a transform. Now the reason for the transform is that you can either transform the grid and make it orient itself to the font, or you can actually transform the font to orient it to the grid. So in my case, I'm gonna just make the font be on the same orientation as the grid. Alright, so there ain't nothing technical about the transform over here, and being that it's a special effects, you always want something extra, you're gonna drop in a mountain, and that way you can have all these various settings you can have, and roughness, and you just want to get the drift, play with the settings a little bit. Alright, so our grid over here is not high res. We're gonna make it 50 by 50. And I like the little squares, even though it's too much. If I want to subdivide this, and I know eventually it's gonna be way too much, computer, it's gonna be CPU intensive. So I'm gonna go group geometry, and I'm actually go ahead and group this is actually use a bounding box, which in my case will be on the X. And since you're going across, you just go across like so, and that should be enough for whatever our mesh over here. Now we're gonna go ahead and name this group something, or we can actually go ahead and do something like this. We can actually name this subdivided, if I can actually type. Right now, something that's really cool about Houdini is actually you have presets on your SOPs, your nodes and stuff. So in my case, I'm gonna just go ahead and name this to $OS, and what the $OS actually does is actually names our group to the same name as the name that you actually label on the top over here. Now that's pretty nice and dandy, but you can actually go ahead and take it a notch farther and save as permanent default, so that way every time Houdini starts up, it has the same stuff. So now I'm gonna go ahead and drop in a new group geometry, and I'm gonna plug this in right here. Now actually, if you actually look at this group geometry, what it has is an OS for the group name, which is, as you can tell, it's group 1. So now if I change it to group version hours, if I look at the name over here, well, it doesn't change immediately, being that Houdini for some reason just doesn't you gotta kind of mess with the settings a little bit, and that way it just updates the stuff. Don't ask me why that is, but that's just the way it is. So for one, I should have not saved with the settings like that, but I should have left just the OS, but it's straight for now. I'll reset it later. So we got our grid set up. What I'm gonna go ahead and do now is actually now subdivide this into little pieces, into a finer detail, and the group in our case is subdivided, and we want to subdivide to whatever resolution that you want. In my case, I can actually go over to 4, of which it's kind of high res. Now it's gonna make me hopefully it doesn't make me freeze. Okay, we got the resolution really high res, pretty good. Now you can actually go ahead and use our Ray Sop. Alright, now this is the same arrangement as earlier, so we're gonna have, as you can tell, I just plugged in subdivide on the ray points and the collision primitives to the font. Now this is nice and dandy, but we actually don't want to transform. You don't want to you can transform, I mean, depending on what you actually really want to do, you can actually transform it like that, but we don't want to transform the points. We want to learn Houdini a little bit. So I'm going to give 2 examples. In my case, I'm going to use point normal intersection, of which what that does, as you can tell, it actually shoots all the stuff down, and if I disable this, you can tell it takes everything out. Or you can use point distance. Now I'm gonna do point distance for example 1, so I'm gonna go ahead and just copy oops, I'm gonna just go ahead, copy paste this. So in example 1, I'm gonna use ray point distance, and in example 2, I'm gonna use ray normal intersection. So first example is gonna be the point distance. It's gonna be really easy, really cheap, really simple, but we're gonna go ahead and do that right now. Yeah, right now. Okay, so point intersection distance is actually what we're gonna be working with. So now what actually this does, if actually middle mouse click on this, you have one point attribute over here, but now if you actually come on the Ray Sop over here, you actually have an attribute called dist, which actually you can actually look on the spreadsheet. And if you actually look at this, it actually has various values, different values for every point. And now what we can actually do with that kind of data is actually use a Ray Sop to manipulate the data, being that I love VOP so much. Now I can actually go ahead and import the attribute, which in our case is actually just called dist, dist. Now it's all, as you can tell, it has one on the side over there, meaning it's not an array of numbers, it's just one float attribute. So you need to change this to a float and change the attribute name to dist, right? And that's from port index 0, being that it's from index 1. And now what you can actually go ahead and do, which would be similar to what we did earlier, is dropping a vector to float and a float to vector, and the x and the z don't change or nothing, but this, if you plug it in over here, what it does is actually do the same thing as transform points. Now you would wonder, why didn't you just do that in the transform points? Well, the reason for that is that you can actually use a little bit more, just a little bit more probably, in VOPs. Now I can use a fit range in this. Now you can actually limit, as you can tell, the effect is a little bit different, or pronounced a little bit differently. So now you can actually have it that as the max, to 0. And now depending on how high the font is, we can actually go ahead back over here to the transform, and depending on how high the font is. Now don't forget that you have a mountain over here, which if you do animate, it's gonna create a different effect on the font below. So if I actually take it all the way down, I think I can probably play with this a little bit. You can have that, in which case the whole name is not actually pronounced as much. So now all you gotta do is actually play with the node over here, which is the transform, and what you get is actually different results. As you can tell, now you know, just need to animate the stuff, and you just, now if you're actually creative, you know Houdini has a lot of stuff, so you can have a switch and this, create another name, plug it in, and once you get everything, you know, with the way you want it, animate the switch node over here, so that way the font actually changes when everything disappears. Let's say you drag everything down, everything disappears. When it comes back up, you can have a different name, you know, all changed up by the switch node, of which pretty much that's it when you think about it. I mean, you gotta kind of play around with this a little bit more and probably, you know, animate some of the stuff over here, but other than that, it ain't much to it. It's just the Ray Sop just doing all the stuff for you. As you can tell, that's some pretty nice stuff too, pretty slick stuff, if you like, you know, depending on how you like doing stuff. Anyway, that's enough for the point intersection Sop, intersection parameter, pretty much, and that's pretty much it. Now we're gonna actually go ahead and do the normal. Normal's a little bit different, so I'm gonna go ahead and drop in the VOP Sop while we at it. But it ain't no different than the point intersection. All we're doing is just getting the values. So in our case, this one is actually point normal, and what this is gonna do is actually just shoot all the data down and give normal data for one. So actually, if you look at the spreadsheet, what we have is normal data, and he has a lot of data. So what we can go ahead and do is actually dive into the VOPs up over here, and being that normal data is actually what we're trying to manipulate, and in this particular instance the Y data, being that everything else doesn't get changed, we're gonna go ahead and drop in a vector to float as usual, vector to float, if I can choose the right one, and we're gonna be getting the normal data, and we just need the y, and what we're gonna be doing is actually comparing whatever values are actually not equal to 1. So compare, and if the values are not equal to 1, right, we want to get the values. So what we're gonna go ahead and do, if you do remember, if I actually go back up and check on the spreadsheet, you have a lot of ones. That's the one that's actually just pointing up, and that's the white surface that you're looking at. So checked on that. Now we need to actually drop in a two-way switch that just outputs a true boolean, true or false value, and what we need to do is actually get those values, which is the point normals. Whichever values are not actually equal to 1, we're gonna get those. Okay, once we done got those, we can actually now work on just that and not any other of the normals. So in this particular case, you can, I don't know, we can try something more like I don't know, let's, for one, multiply the values by just a minimal number. Of course I know it's gonna be kind of big. I want to do a constant. I want it to go up on the top, and I'm gonna go ahead and add the original point positions to the new normal data that's just been calculated, and output that as the new point positions. Now we get the whole thing, you know, you get the values being pushed down, of which that might be good in your instance, I'm not sure. But if you actually wanted it to be up, you can actually negate or convert the values to higher values than, I mean, if it was a negative, make it positive. That's what it's supposed to be doing. That's what the negate does. You can check on the help documents, see what it tells you, and it negates the values pretty much. Well, it doesn't say whole. Okay, so you get the values up, and well, it's a lot of mumbler, but it does what it's supposed to be doing. So now you can actually go ahead, use your Sop over here to, you know, hide the rest of this stuff and move it up a little bit. Stuff comes back up. So I mean, it's all a matter of preference of what you actually really want to do. And I'm guessing that's pretty much it for the lesson, and ain't much to it on the VOPs. I thought there'd be much to it, but ain't nothing to it for real. Let me see what happens if I actually add an absolute to this. I'm not even supposed to be doing this, but I'm doing it. And I guess, wow, changes the formation a little bit. And I guess all you gotta do now is just play around with the stuff a little bit more. Really can't emphasize on that. And I guess if you have a zero, height, you have a smoother interpolation of the data, of the normals. So and that's pretty much it as far as for the lesson, and that's the Ray Sop. More of an overlook more than it is a tutorial, so I really wouldn't count it as a tutorial, but I'm gonna post it though, just for the sake of the people beginning Houdini and stuff like that. So yep, pretty much that's it. I guess I'm out on this one, so out. See you on the next one for sure.